Okay, let us continue the second part of today's course. Class. Okay, so this notation. Okay, and A, B. Okay. Okay, is the inner product of vectors vectors A and B. Okay. Okay, and this notation is the Euclidean norm of vector A. Okay, the vector x beta can not bold be expressed as. Okay, let us see. Okay, x beta is equal to, we only need to copy the matrix. Good, we can copy this and paste here. Okay, so and then we multiply this matrix and this vector together. Okay, please note that it's an n by m matrix and it is an m by 1 vector. Okay, so the result should be n by 1 vector. Okay, so it is equal to n by 1. Okay, so first brackets and column vector, and the first term is x11 times beta 1 plus dots x1m times beta m. Okay, so this can be written as a form of summation. Okay, J is equal to 1. Okay, italic to M. Okay, and x11. Okay, and this should be changed to J. Okay, and times beta 1. Okay, and this one should also be changed to J. Okay, J. Okay, good. Okay, and vertical dots. Okay, and the last element is similar to the first element. Okay, except for 1 is changed to n. Okay, so this 1 is changed to n. Okay, like this. So align at the equality. Okay, good. So it is equation 6. Okay, good. So next, recall that beta holds, not bold, m adjustable parameters and x ij is equal to phi and j, index j and of xi, like this. Where phi j is a function of x and xi is equal to 1 to n. Are independent variables which are a part of the data set. In machine learning, it is reasonable to assume that beta and excuse me, x are real. Then excuse me, then the square of the norm of x beta is equal to summation and there are 1 to n. So I is 1 to n is 1 to n. And summation, this term j is equal to 1 to m xij. 1 should be changed to I, and beta j. And let us put it into a pair of parentheses and square. It is equation 7. Therefore, the fourth term of 1 can be computed as follows. Okay, so let us go to equation 1. Okay, equation 1, and copy the fourth term. Okay, and paste here. Okay, so partial beta transpose x transpose x beta over partial beta is equal to equal to partial the square of the norm of x beta over partial beta. Okay, and it is equal to, okay, let us copy and paste, and this term is equal to this term. Okay, delete this term and replace by this term. Okay, and align at the equality. Okay, good. So this is equal to partial over partial beta. Summation I is equal to 1 to n, and the square of the summation j is equal to 1 to m xij beta j. Okay, and it is equal to partial over partial beta, and summation. Okay, I is equal to 1 to n. Okay, and let us insert parentheses here, and let us expand this term. Okay, so we have, okay, summation j is equal to 1 to m. Okay, and xij square. Okay, and beta j square. Okay, like this, and plus 2 times excuse me, 2 times, okay, jk is equal to 1. Okay, to m. Okay, and j is not, and j is not equal to, okay, j is not equal to, okay, k. Okay, and this term becomes, okay, xij beta j times xik. Okay, so replace by k. Okay, xik beta k. Okay, like this. Okay, align at the equality. Okay, for brevity, let us define this, okay, as partial over partial beta and a. Okay, So we define this term as A. Okay, so align at the equality. Okay, good. Excuse me. Okay, so it is equal to, we know that the partial derivative of a scalar to a vector is equal to a vector. Okay, and with 3 boxes here. Okay, and the first term is partial A, okay, over beta 1. Okay, let me search for beta 1. Okay, here is a beta 1. Okay, and dots. Okay, horizontal dots. Okay, and the final, the last term is partial A over partial M. And transpose. Okay, like this. Okay, and this is equation 8. Okay. Where, okay, let us compute, okay, partial A over partial beta M. Okay, partial A over partial beta M, okay, which is equal to partial over partial beta M, and put A here. Okay, like this. Okay, and because the partial derivative is a linear operator, okay, so we can interchange the order of partial over partial beta M and the summation. Okay, like this. Okay, so we can move partial over partial beta M here. Okay, and when taking the partial derivative with respect to beta M, okay, we can only keep the terms which have beta M, and delete the terms which that do not contain beta M, because they are constant. Okay, so J is equal to 1 to M. Okay, so the only term that contains beta M is xi, okay, M. And beta M. Okay, so only keep this term, and we can delete this summation. Okay, like this. Okay, and for the and plus 2 times. Okay, for this term, the only term that let us rearrange the order of these terms. Okay, xij and xim. Okay, beta j and beta k. Okay, the only term that contains beta m, so we can change k to m. Okay. Okay, and we move beta j, okay, in front of the beta m, and we also change this k to m. Okay, Okay, so now j is equal to 1 and j is not equal to m. Okay, so can you get this? Okay, summation j is equal to 1 to m. J is not equal to m. Xij xim beta j beta m. Okay. Okay, let us align at the equal sign, equalities. Okay, if you cannot understand this step, you can calculate from this equation by yourself. Okay, on a paper with a pen, and do not look at our blackboard. Okay, try to do it yourself. Okay, so sorry. Okay, so next it is equal to summation I is equal to 1 to n. Okay, and take the partial derivative with respect to beta n. So this term becomes xim squared, times 2 beta n. Okay, so we move the factor 2 in front of xim squared and beta n. Okay, like this. Or we need to put it. Okay, so wait me a minute. Okay, so we need to put this into a pair of parentheses, like this, and plus 2. Okay, this term 2 times this term. Okay, and take the partial derivative with respect to beta m. So beta m will disappear, and its coefficient will remain. Okay, so it is summation j is equal to 1 to m. J is not equal to m. Xij xim beta j. Okay, align. Okay, so next it is equal to here is 2. Here is 2. So we can move the constant outside of the summation. Okay, so we have summation. Okay, this term. Okay, and we can delete 2 here and delete 2 here. Okay. Okay, so let me align again. Oh, sorry. Align, at the equality sign. Okay, so that it is equal to, please note that here is an xim squared. Okay, here is a term xim. So they have a common term, that is xim. So we can move the term xim out of this pair of parentheses. So we can have the same equation, and we take the xim out of the parentheses. So this square disappear. Okay, let us remove the superscript. Okay, so we have xim times parentheses xim beta m plus summation j is equal to 1 to m. J is not equal to m. Xij beta j. Okay, and please note that this term is equal to this term. Okay, this term with J replaced by N. Okay, so we can combine these two terms together. Oh, it is 25 minutes. Let us take a break.